All right, Algebra 2, we are ready for operations with functions. When we say operations, we mean we're going to add, subtract, multiply, and divide. We're not going to perform surgery, okay? Just add, subtract, multiply, and divide. So let's use these two functions. F of x is x minus 3. G of x is x squared minus x. So when I say f plus g of 3, looks kind of funny written that way. It really just means f of 3 plus g of 3, okay? I can just take f of 3 plus g of 3, which is, let's see, f of 3. 3 minus 3 is 0. G of 3, 3 squared is 9, minus 3 is 6. So I get 0 plus 6 is 6. That's if there's a number, 3. That's just what you do. I'll take f of 3 plus g of 3. Now, if it's f plus g of x, it's similar in that I want to take f of x plus g of x, but I'm not going to just get a number. I'm going to get another expression. I'm going to have x minus 3 plus x squared minus x. Well, now I'll combine like terms. X minus x, that's 0 x's. So I really just have x squared minus 3. That's what f plus g of x is, x squared minus 3. I could have written negative 3 plus x squared. I just usually like to have my positive term first. Okay? The domain of f plus g of x is just the union of the two domains here. Okay, so in other words, let's think about it. These domains are just all reals. There's nothing that, there's no denominator. I can use any x I want. So the domain of the f plus g of x is all real numbers, which we sometimes use this big R to show, as we did previously in the domain lesson. I don't care if you write all reals. That's fine as well. Okay? F minus g of negative 6 then will be f of negative 6 minus g of negative 6. Okay? So I just have to stick negative 6 in for x. Negative 6 minus 3. Okay, I'm putting that in the f function. Negative 6 minus 3 is negative 9. Minus what I get when I put negative 6 in for x down here. Negative 6 squared is positive 36 minus x value of negative 6. Okay, so g of negative 6, I'm subtracting that negative, I get 42. Okay, so I'm taking f of negative 6, which is negative 9, minus g of negative 6, which is 42. Negative 9 minus 42 is negative 51. Okay, so be careful with all those negatives. It doesn't hurt to write more down and not keep it so much in your head, okay, because people get that messed up sometimes. F minus g of x, sometimes we just write f minus g. Okay, if you don't see a number there, you assume they mean of x. So I'm going to take f of x minus g of x. So I'm going to take the f function and subtract the g function. Just be careful that you don't just write it down x minus 3 minus x squared minus x. Because now you're not subtracting the whole g function, you're just subtracting x squared. You want to subtract the entire g function. So please be careful writing that. Okay? So that's really x minus 3 minus x squared plus x. I end up getting negative x squared. I have 2 x's minus 3. Now I'm contradicting what I said earlier, aren't I? When I said I like to have my positive term first. I also like to write in descending order of x. So this is an this power is 2. This is a second degree term. This is a first degree term. And then there's no x in that one. A lot of times we go in descending order with the exponents, okay, when we do a polynomial. So f minus g of x is negative x squared plus 2x, because I have the 1x and the 1x here, and then minus 3. And the domain, again, is all reals. There's no denominator to worry about. There's no square root that, where I have to worry about a square root of a negative. I can stick anything in for x here. The domain for these functions are all reals. Okay, so to add functions, you just add them together. Subtract functions, you just have to be careful that you distribute the negative. Let's go down below to multiply and divide. Same functions, okay? I'm trying to use these same functions in the middle so you can make some comparisons on these operations. F times g of 2, look how it's written. People get that mixed up all the time. They're like, what's that mean, FG2? It's not FG2, it's F. We're multiplying the two functions together, okay? I'm taking f of 2 times g of 2. So f of 2, let's see, I put 2 in for x. 2 minus 3 is negative 1. G of 2, 2 squared is 4, minus 2 is 2. That's negative 1 times 2. So f times g of 2 is negative 2. I simply multiply the two together. Again, the domain is all reals. Oh, well, never mind. I didn't do the f times g of x yet. Okay, f times g of x is x. I multiply the two functions together. Okay, so I have to multiply the f function times the g function, which means I'm going to FOIL. Looks like I get x to the third minus x squared minus 3x squared plus 3x, right? That's a minus 3 times a negative x. So I get x cubed minus 4x squared plus 3x. I was combining the x squared terms, negative 1 minus 3, and the domain is all reals. Here's where the domain might be different, guys, because, I'm dividing, and I can't divide by 0, so I'm going to be careful when I get to f divided by g of x. F divided by g of 4, just like the previous ones, I'm going to take f of 4, I'm going to take g of 4, and then I'll divide them. When I put 4 in the f function, 4 minus 3 is 1. When I put 4 in the g function, 4 squared minus 4 is 16 minus 4, or 12. So the answer to f over g of 4 is 1/12. F over g of x, I take my my f function and divide it by my g function. Now, because I'm doing division, we know the denominator is not allowed to be 0. Isn't that true? No 0 in the denominator. So x squared minus x can't be 0. This denominator can't be 0. So let's factor that out. Okay, and then I realize x, this will be 0 when x is 0. X minus 1 is 0 when x is 1. So the domain is all reals except 0 and 1. If I put 0 in for x, I get 0 minus 0. That's 0 on the bottom. Can't have that. If I put 1 in for x, 1 squared minus 1, 1 minus 1 is 0. You can't have that. So the domain is all reals except, let me move my head, x cannot be 0 or 1. Okay, anything else is fine. All reals except 0 and 1 would be the domain for that. Okay, that's how you add, subtract, multiply, and divide, guys.
Please excuse me for this interruption. At this time, all even-numbered classrooms are dismissed for the day.
Sorry about that little noise. It was the end of the period. Anyway, composition of functions is the other operation. Okay, we did adding, subtracting, multiply, divide, and now we're doing something called composition of function. It's when you take f of g of x. It's denoted by this little circle. Okay, that's read f of g of x. Okay, or just f of g. Okay, f of g of x. So, what we're going to do, I'm going to have these be the functions. F of x is 3x minus 1. G of x is x squared plus 1. And h of x is x plus 1 over 3. Okay? And I'm going to start with, it matters which way we write this, okay? Like I said, this is f of g of x, which I would write this way, f of g of x, so the same way. You either use the circle or you do extra parentheses, okay? So g of f of negative 1. We first want to figure out the f of negative 1. Well, that's 3 times negative 1 minus 1, or negative 4. Okay, I figured out what f of negative 1 was by putting negative 1 in the f function, and I got negative 4. So really what I'm asking for now is g of negative 4, right? Because I figured out what f of negative 1 was. G of negative 4 means put negative 4 in the g function. So I have negative 4 squared plus 1. That would be 16 plus 1. The final answer is 17. G of f of negative 1 is 17. Or G of f of negative 1 is 17. It doesn't matter if you use this double parenthesis notation or the circle notation. Okay? Try h of f of negative 7. H of f of negative 7. You want to do the f of negative 7 first. So I'm putting negative 7 in my f function. 3 times negative 7 minus 1 is negative 21 minus 1. You get negative 22. So really what I'm asking for is h of negative 22. Okay, I found my f of negative 7 by putting negative 7 in the f function, got negative 22. So if I'm asking for h of f of negative 7, I'm really asking for h of negative 22, which means I put negative 22 in for x in the h function. Negative 22 plus 1 is negative 21. So I end up getting negative 7. Okay, interesting. H of f of negative 7 ended up being negative 7. Okay, it's an interesting situation. Okay, let's try this next one. Some people have trouble when it's the same function twice. Oh no, that's not what this is. H of f of g of 3. Oh goodness, right? I'm going to write that as h of f of g of 3. Lots of parentheses, okay? The first thing we do is g of 3. So the g function says to take x squared and add 1. So that's going to be 10. So I have h of f of 10. I'll put 10 in the f function. That tells me take 3 times 10 minus 1. 30 minus 1 is 29. So now I just have to take h of 29. The h function says take x, add 1, and divide by 3. 29 plus 1 is 30. Divided by 3 is 10. So that final answer is 10. Okay. Now we'll try f of g and g of f, just of x. Okay, notice there's not a, if you look at your notes there for a sec, there's not a number. It's just f of g, g of f.